I'm here today at Allen Brothers to take a look at the processes that go into manufacturing some of the fittings that we all use sailing. They use a range of tools which go all the way back from some of the classic machining tools all the way up to this extremely high-tech CNC machine behind me.
We'll start with something simple, and this is an Ilka or a laser main sheet traveller block, and after the parts are moulded and pressed, these are constructed by hand. It's fascinating to see the range of machines that are required to turn raw materials into the sailing products we use every day.
So here we have the equivalent of a metal pasta making machine. Metal gets fed through this machine which will flatten it, and then it comes into our big press where we cut the shapes out. So for example, the stainless sides of our 20 and 30mm blocks, lots of shackles, they get cut out on here. But the good thing about this machine is we can also use it for other operations. So at the moment there's actually trapeze wires being bent, and these will be loaded in by hand, and then it will get bent one after the other as they're loaded and taken out.
High precision fittings require high-tech machinery, and Allen have recently invested in a 4-axis CNC machine.
So all the tools you see along here are jigs and vices and different tools that will be loaded into our VMC machine, which is just the other side of this rack here.
Right. This is the VF4 SS hash, and what it can do, this is the 4 axis over here. It can change. They can machine all different sides, drill, etc. And over here, this is the probe. This is to height all the tools and the cutters. And that's the sensor to locate for the tools, so it gets the right measurements. And then over here, this is the program. Obviously, I can call any programs that I make for all kinds of jobs. And this is here, this is to rotate the table, so I get all my measurements right as well. And these are all my tools over here, but they've all been hired up.
A second CNC machine is in action while I visit, which is milling out stanchion bases, as Ben explains.
So these are some of our stanchion bases. They start off as a square cube of aluminium, and then they get milled out in various processes to get the different shapes and holes put into them. So these ones here are just about to be loaded into the machine, where they will then get this cut out, which is purely to just reduce the weight of the product, and all of these ones here have just been done. So there's a few left to go, and there's one going just at the moment.
Another fascinating tool was the lathe, which is used to turn down many of Allen's products.
Here we have one of our big lathes. Essentially what this machine does is we load a big bit of rod into it. It will get fed through into the main compartment here, where it then gets turned down into various shapes. We have one of our pad ties. This would have been one long bar, but in different sections. So this has actually been turned down with the various shapes put into it, and it will drop off on the other side when it's all complete.
Most sailors are familiar with ball stoppers on control lines, and this is how they're made.
So this machine is currently moulding our ball stoppers. It's a 4 impression tool, and what that means is it's creating 4 products from one tool. This central part is the sprue. This is where the plastic is injected into the tool. This will get cut off, ground down and reused in another product later on down the line.
At the same time, another moulding machine is making hatch covers, something that we see on a lot of dinghies and also many keelboats. 3D printing is playing an increasing role in manufacturing, and Allen are fully embracing this.
Another modern industry that we utilise is 3D printing. In this example, we have a 1-string rake adjuster. So the entire product, other than bearings, is 3D printed. You only have to pull 1 string and it maintains the rig tension and keeps your rig exactly how you want it. We also have utilised 3D printing of metal parts. So this is an early prototype of an actual spreader route. So that is stainless steel, but it's 3D printed. It means that the product no longer has the weaknesses like a welded part would have. It comes complete as it is, and means that we don't have to tool up. So previously, to make a product like this, you'd be looking at tooling up for the socket, for the bracket that would go around the mast, and then you'd have to come up with a welding rig to weld it on. So all that becomes a very expensive process, whereas although the actual 3D printing process is relatively expensive still, the actual part cost for us is lower and better.
Much of the block construction and thimble printing is done by hand, and then it's bagged and weighed to make sure that quantities are correct. When it comes to dispatch, Alan makes sure that the most popular products are closest to the packaging area.
So once all the products are completed, they come into our warehouse here where they're stored, ready to be picked and sent out to the customers. Essentially this area here is our more popular items, the things that we pick big quantities of. And then as we walk further down the aisles, we have rows and rows of more and more components and products. And essentially the further away from the main centre it is, the less often those items get picked. Having looked at some of the red balls that were being moulded earlier, you can see here we actually have them all in stock, ready to go out to the customers. They're in bags of hundreds. This one's been opened where we're sending smaller quantities, and we have the other colours just next door. So when you're picking for various people that want various colours, it's all next to each other, ready to go.
It's not just making our fittings that the Alan team do, and they are passionate about supporting the next generation of sailors who are coming through, as we can see with Steve Hall here at Otter Week at nearby Burnham-on-Crouch.
So here we are, this is the last day of Otter Week for us, and there's myself and a couple of other guys from Alan that have been helping out with our own children and also supporting the club and just trying to make this the special thing it is to get kids into sailing and enjoying it.
It was great to see the kids out on the water at Otter Week and seeing the Alan team supporting them, and we all have to do our bit to make sure that they come through enjoying the sport, because after all they are the future of sailing. With highly skilled engineers and such specialist machinery, it's good to see the Alan team taking on custom projects often from outside the marine industry.
So here we have a sample of a shackle that we were sent by one of our customers. It's got a bit of a unique shape to it. They're looking to source this, but they can't find anything off the shelf. So the guys in the tool room here have been trying to utilise tooling that we already have by using some similar shackles that we already make and some tooling that we already make, and essentially adjusting the tooling to try and replicate the shape that our customer's looking for.
Every so often Alan get involved in projects which are truly out of the ordinary.
And then the latest thing is outside of sailing. We've got a stuntman that came to see us, which was very exciting. And he had a show reel of him being blown off buildings and exploded and shot across. And he explained that within the stunt industry they're using blocks from the sailing and climbing industry, which was fine. But he was saying they rig up all of these really rigging solutions for all of these different stunts, and then they decide they need a bit more purchase and they have to de-rig the whole thing. So he got an idea that he came to us with like a high-speed snatch block. He'd seen snatch blocks, but obviously you couldn't use a sailing one. He needed something that was for human suspension. So we worked with him to develop a big, heavy snatch block basically for the stunt industry. And that's something, again, because it's all in-house, everything there can be made here, which not everyone offers, I suppose, is what I would say.
Alan also make various class-specific products for boat builders.
Most of our stainless steel and aluminium products have to be rumbled. It takes the burrs off and it gives them a nice sheen. So these products here, it's a 29er bow bar, which you'll see at the front of the boat. These ones are ready to go into our rumblers. They've got the end caps on to stop the stones from going inside. These ones have come out and you can see the difference. It just gives them a much nicer finish, ready for anodising, so you get a better finish overall on the anodising. So this here is our big rumbler, and you can see Ben's placing in the 29er bow bar units. This machine essentially just shapes and polishes all of the components.
An area which people may not associate Alan with is spars. And so we took a look at some of the processes which are involved in making their dragon masts.
Aluminium comes into us in a soft raw state, which means it needs hardening to make it nice and stiff. We've custom built our own oven to put the mast into. Basically, we heat them up, we cook them, that stiffens them up and makes them nice and strong and makes them perform better.
The spars are first cut on their leading edge for the taper at the top and then fed into a machine that is known in Allen as Big Red.
So here we have Big Red. This is where we load the mast into once a section has been cut out of it to essentially taper it. So the mast will be loaded in, and then each one of these tools is clamped down onto the mast to fold it back together to create the shape that will be the taper, which is then welded closed at a later stage. So here we have a selection of dragon masts that have just come out of Big Red after being clamped and kind of closed down. They're now at the stage where they're ready to go through into the welding bay, where they'll be pushed together slightly more and then welded shut and to get that nice taper finish.
The mast is then brought into the welding jig, which is then pre-bent, and the initial weld takes place before the machine takes over.
Hi, this is our Dragon welding rig. As you can see, it's all rigged as a pre-bend. So when we do the welding, we don't get any heat drawback from the bend coming back towards us. This is our automated welding machine, which is all programmable considering what mast we've got in the rig at the time. And once set up, it is literally press the button and go, which gives us a full, complete, non-stop weld.
The combination of Big Red, the jig, the skill of the operators and the welding machine make for an extremely accurate and repeatable taper on the mast.
So this process here is where we have the raw mast ready to be fitted out with sheave boxes, goosenecks, all the holes essentially that need drilling into the mast for the fittings. So it's placed in this drill and it will rotate at exactly the right location so we can get the holes in the same spot every time and get everything the same.
The end result is masts which are highly sought after on the Dragon circuit. I hope you've enjoyed this tour around the Allen factory. We're going to continue bringing you things like this, as well as news from sailing events on this channel, so please do subscribe using the button down here. And take a look at sailworld.com and yachtsandyachting.com for all the latest news from the world of sailing.